But being a physicist, we are more interested into what happens to this lubricating fluid as a function of system parameters. Okay. So we looked what will be the lubrication will be available only if there is a stable green liquid underneath the drop. If because by somehow this green liquid is not there, then your drop is directly sitting on top of a solid surface, there will be strong friction, and then this liquid drop will not move. So we looked at some of the stability criteria, and we found that you can have a two situation where there is a thin amount of liquid between the drop and the solid surface, or the liquid between the drop and the solid surface will be unstable and will be ruptured as individual droplets. Okay, in this case, so this we call as a floating system, this we call as a sinking system, and this sinking system, the drop will not move, and on the floating system, the drop is floating on a thin lubricating layer, and it will move nicely on this lubricated surface. So here are the experimental results. So if the delta gamma or the floating condition is not valid, the liquid drop is not moving, whereas if the delta gamma or the floating condition is met, this liquid drop will slip on the surface forever. Okay, and then we are looking at the hydrodynamics of these liquid drops based on various parameters. What is the role of surface tension, for example? How does the water drop move? How does the ethanol drop move? And so on and so forth. And then come up with this morphology diagram. How does the drop velocity depends on the viscosity of the lubricating fluid and the surface tension of the top liquids, and so on and so forth. All the fundamental studies of the system. But the idea of the system is to somehow come to this floating regime where there is a stable liquid between the drop and the solid, and resulting to the slipping drop. We also study the evaporation. For example, evaporation is a very fascinating phenomena, especially for the mechanical engineer people, because they use evaporation for the heat transfer application. Okay, so we also study evaporation on dry surface and also on the lubricated surface, because on the slippery surfaces the drop is moving isotropically. There is no pinning, there is almost no friction. So when the drop evaporates, the entire drop contracts. Okay, whereas on the solid surface, when the drop evaporates, the end point of the drops they get pinned. So the drop diameter remains still constant, only the curvature of the drop decreases. Whereas on the slip surfaces, when the drop evaporates, the entire drop contracts because you are allowing them for the droplet to move, because you have a slippery interface. So we look at the variety of statics and the dynamics of the slippery behavior, and comparing the slippery behavior from the dry surface to the lubricant surface, and look at some of the detailed features of those evaporation.